Right, areas, more complex shapes. Now this is going to be, we've done the triangles and the squares and the rectangles and the circles, and now this is going to be putting the shapes together. Right, so let's do I'll do this freehand. I'll do this freehand because I'm a bit too hard. See what I can do then. So I've got that, and then on top, let's see if I can put a triangle on top. Will this work? Oh no. Oh, put it on the bottom then. Something like that. Something like that. I don't like that. I don't like that. I want to put it on the top. I'm going to put it on the top. Whoop, I missed. There. Perfect. Right. So, imagine this was the side of a house or something, yeah? And we wanted to find the total area. So, we can see what we need to do is we need to work out the area of the rectangle and we need to work out the area of the triangle and add the two together. That's all we need to do. So although it's more complicated or complex shape, it's still the same procedure except we're going to do twice as much work. So let's put some uh, 8 meters and 10 meters, and we need the total height here, which is 14 meters. Now there is the vertical height that we need to go to the top of the triangle. So area A is simply 8 times 10, which is 80 meters squared. And area B is the triangle, which is half base times height, which equals a half times the base of the triangle is the same as the base of the house. So that's 10. So a half times 10. Now the height of the triangle. Now the height of the square bit, the rectangle, is 8. The total height is 14. So 14 takes away 8 is 6. So that will be 6 for the height of the triangle. 6 times 10 is 30. Half of that is 15 meters squared. So the total thing is just going to be 80 plus 15 is 95 meters squared. Oh, like this, yeah. So yeah, so you're moving around. You've got different shapes. So let's have a look at this one. So this, and in there is a circle. Now, imagine this was a piece of wood or something like this, and we came along with a big drill and drilled a hole in it. Yeah, and we want to find the area of the bit that's left. So it's the area of the whole thing minus the hole in the middle. So we've got to have 2 centimeters for the radius of the circle, and that's 2, that's 4, so that's call that 20 centimeters and 18 centimeters. So this time we need to work out the area of the rectangle and subtract the area of the circle. So the rectangle is 20 times 18, which is 360 centimeters squared, and the area of the circle is pi r squared, which equals, I'm going to use the pi button on my calculator, and so that equals pi times 2 squared, which equals pi times 4, which equals, right, what's that? So shift pi times 4 equals 12.5, let's call it 12.57. 12.57. I've rounded it a little bit, centimeters squared. So to find the area of this bit, yeah, the bit that's left, we do 360 minus 12.57. So 360 minus 12.57, which is 347.43 centimeters squared. Now, I think what I need to do here is, because I've made the error of rounding before I got to the end. So if I do that pi r squared a bit again, and I use shift pi times, well, r squared was 4, wasn't it, times 4, that actually comes out to be 12.56637.061. Leave that all in the calculator and then do 360 minus the answer, which is that one, and I get 347.433629 two decimal places, it comes out the same, 347.43, but sometimes it doesn't. So made a bit of a mistake there. I'm going to say don't round till you get to the end. Otherwise you may be, if that had been a 5, then this would have been 4 and you would have been just a little tiny bit out. Yeah, so don't round till you get to the end. So there's one there where you're working out the area of something and you're taking it away. You're taking it away. Now, this is always a good one to do. And a hard one to draw. 20 centimeters. Now, what's the area of this? And this is a semicircle. Okay, a semicircle. Now, if the area of a circle is pi r squared, then the area of a semicircle is going to be half of that. So, divide by 2. Yeah? Now, okay, so this here is the diameter of that semicircle thing. No, you don't have a diameter of a semicircle, do you? It's the diameter of the circle. So in here we're going to do pi, remember the radius is 10 now, 10 squared divided by 2, which equals pi times 100 divided by 2, and so that will be shift pi times 100, I put equals there, divided by 2 equals 157.079. Now, and there's more, there's 6327. Now, round to 2 decimal places perhaps, and that 9 adds 1 onto there. So 157.08 is 2 decimal places, and I've forgotten in there to put centimeters squared. So a semicircle. So we've got all sorts of weird and wonderful shapes here. So it's getting more complicated. It's getting more complicated. So let's do this. There's a big circle, and there's the middle, and I'm going to do this, and I'm going to do this and draw a triangle there. Now this is as hard as it gets, yeah? Or is it? Yeah. So let's call this 6 centimeters. Now that's all you need. That's all you need. But what we want to find out is the area of that. My goodness, the area of that. Can we do that? Oh, I think we can. Yeah, I think we can. Now, what we're going to do, first of all, on here, no good finding all that area and taking the triangle away, because then we'll find the area of the yellow plus all that bit there. We don't want that, yeah? So we'll look at this as a quarter of a circle. A quarter of a circle. So if we find the area of the quarter of a circle and then take away the triangle, we'll be left with the yellow bit. So the area of a quarter of a circle is pi r squared. That's for the whole circle. Now we only want a quarter of a circle, so let's divide by 4 this time instead of divided by 2. So this is going to be pi times, this is the radius, 6 squared divided by 4. So pi times 6 squared is 36 equals, and then divide that by 4 equals 28.2743. That's enough numbers, yeah? Now, the area of the triangle is half base height, which is half times the base, which is 6, times the height. Well, no, see, from the middle to the outside is the radius of the circle. So from the middle to the edge again, that's the radius. So this is also 6. So 6 is the 36, and half of that equals 18. So if we take our 28.2743 and take away 18, we get 10.2743. Lots of threes, yeah? And let's round that 10.27 centimeters squared to 2 decimal places. Okay, so that's that one there. Okay, so you don't rush in and go, oh yeah, pi r squared, because if you do pi r squared, take away the triangle, you're left with all of that rather than just that little bit at the top. Ooh, so you're taking away, it is complicated, yeah? So let's have a look at some of these. Carlos is laying concrete to make floors, I think I'm doing a different colour. Floors of 2 rooms. The dimensions of the rooms are shown below. So we've got 2 different rooms, a rectangular room and a triangular room. He needs to use 0.1 meters cubed of concrete to make 1 meter squared of floor. Don't get too hung up on this. The concrete will cost £65 a metre. How much will it cost to buy enough concrete for the floors? Right, so first of all, let's work out the area of the floor. So 7 times 3 equals 21. And this is half base height, which is half times 6 times 2.5. Alright, so 0.5 times 6 times 2.5, which is 7.5. So the area of the floor area is 21 plus 7.5, which equals 28.5 meters squared. Now, so we know how many meters there are of floor. So now we've got to work out how much concrete. So he uses 0.1 for every 1. So it's a tenth. A tenth. So if we take this number, 28.5, and divide it by 10, we get 2.85 meters cubed of concrete. Now, how much is it going to cost? £65 a metre cubed. So now we've got 2.85 times £65. So 2.85 times 65 is 185 pounds and 25 pence. Oh, it's tricky, yeah? Now, what's Samira up to? Now oh look at her, there's loads of line there, so this must be hard. Samira is painting a ceiling. 1 litre of paint can cover 8 metres squared. A section of the ceiling is shown below. There are circular light fittings, yeah, each with a diameter of 20 centimetres. Samira doesn't want to paint over these. Right, so we've got the light fittings. Here's a big light fitting, yeah, with a diameter of 20 centimetres. But this is in meters. Now, 1 litre of paint can do 8 meters. We're trying out how much, whether 1 litre of paint is enough. So we need our answer to the area of the grey shaded part to be in meters. So probably best to convert 20 centimeters to meters by dividing by 100, which equals 0.2 meters. Now this is the diameter of the light fitting diameter. So the radius is going to be 0.1 meter. Now, the area of a circle. The area of a circle is pi r squared. Now, we've got 1, 2, 3, 4, 5, 6 circles, so we're going to multiply that by 6. And r squared is 0.1, so we've got times 0.1 squared times 6. Right, pi button to the rescue. Pi times 0.1 squared times 6 equals that, which is 0.18849 meters squared. Right, so that's the light fittings. Now, we've got to work out the area of everything and take away that little bit there. So the area of everything is 4.5 times 1.8. So 4.5 times 1.8 is 8.1 meter squared. Right, so the area of the grey is 8.1 minus 0.18849 minus 0.18849, which equals 7.91151 meters squared. Now, 1 litre of paint can do 8 meters. Our area to paint, the grey bit, is 7.91151. Therefore, 1 litre of paint is just enough. Right, so 1 litre covers more than area to paint. Good, yeah, that's always worth putting that little line at the end, something like that. Or you could say, well, 7.911 is less than 8, therefore you can paint the ceiling and nothing left over. Yep, so that's fine. Any more questions on that? No, that was it. So there you go. So that was quite a tricky lesson there. Worksheet on that with semicircles and triangles and bits missing and bits added on. So that's that one. So see you in the next one.